Okay, last time we have already started with the analysis phase. And we said that the analysis phase is more about requirement gathering and requirement structuring. When we said about requirement gathering, we have already discussed so when we talked about requirement gathering or requirement determination, we have already discussed the traditional way and the modern way to collect this requirement. And then we said that after we have this list of requirements, we are going to structure them or to make a modeling for them. Because we as a software engineer, as a software developer or a software designer, we should have different format how we formalize the data that we have already collected it. Because we expect that somebody else is going to read this data. So we started with the requirement structuring, which is how to make a graphical model for this requirement. And we said that there are two parts in the requirement structuring. The part that concerning this, how we make the graphical model for knowing different domains or that we will have, plus the different scenario and the sequence of actions based on different role for the who is going to interact. So the first part concerning the data flow or the scenario, how it's going to take care, what will happen in this project, we did it using object-oriented approach. The object-oriented approach was using use cases model. Today we have to finish the part concerning requirement structuring, and we will finish today the analysis phase. And next time we will start with the design phase. By the way, I hope that all of you have already submitted your assignment. I haven't double checked. Today I will start correcting them. If anyone before I will start with this lecture, if he has any question or feedback for assignment, let me know. So if everything clear, because assignment will be somehow sequential. That the last part talk about the planning, and we expecting now, maybe by end of this week, because today we will finish the analysis phase, so we'll have another assignment. We expect to have 4 assignments in this course. Each one will be 10% of the overall grade. So 1, 2, 3, 4, so it will be 40%. And there will be 30% for the group work project. I think group work project, we can start discussing it by the end of this month because we need to have some progress in the course. The group work project, I will break you down to different groups, the whole students. And then I will maybe publish different subjects and each group can choose a subject. It doesn't mean that 2, 3 groups can choose the same subject, just a subject. And you are in your project, you have to follow up different phases when you're doing your project. So the project will be a group work. The assignment will be individual. And the project will be, the deadline will be the end of the semester for the project. Are you still can see my screen? Because I see that you still can see my screen? Okay, perfect. So if anyone have any question concerning assignment or project later, he just can send me an email. I reply, do my best to reply in the same day. And don't forget that there is a virtual office. And you can also join me at my office in Chilewa campus if you can, if you have some question. If not, I have already published a virtual office hour. It is using Zoom platform. So just drop me an email, you telling me that I want to be in the Zoom hours to block for you a time. Let's return to here if you don't have any question or feedback concerning assignment. And I will try I will send you a survey about your feedback so far about the course. So please take it seriously. To send me your, I will ask you some questions. I start preparing it. It is very important, and it is a professional way how we deal with, because this course, delivering this course is a project for us. So the feedback from the user or the client, in your case you, it's apart from this process. I will send you a survey, and do your best that you reply to me by survey, and don't be afraid or shy for answering some questions. No, I said from the beginning, we are dealing with this with our team. I'm not your instructor. I'm more than your coach. So this process, getting the feedback from you, it is part from the way I will going to deliver this course. So this is why when you receive an email from me concerning the survey, I will appreciate that most of you, they are going to answer the questions of the survey. Let's go to today's lecture. So based that the part that now we have the requirement, and based on the requirement, we make the use cases. We know that each user, what's the different functionality that is going to use. And we have already made this graphical modeling using object-oriented UML diagram. This is about the data flow or the functionality and the actors, how they interact with the system. Based on the requirement that we have already collected. Perfect, finish it. Now we are going to talk about the second part about the data modeling. The use case tell me more about the functionality modeling and the different scenarios and the sequence of events that will happen in this, that this user will have access for this will do this function, and this user will do this function. This is use cases. However, there are some data is going to be stored in this project. Most of the information system, they should have a database system, and they should have a data that is going to be stored and stored within this project. And later, you are going to retrieve different reports based on the data that's being stored. So suppose that you have a library, or you are building a new library at your home, and then you have a set of books, and then you put shelves, and then you start putting books on the shelves without make a special indexing for them and do it in a randomly way. Put science books with literature, with math, with physics, put them in the same shelf. And later, if you are going to retrieve one of the books, maybe you will take hours to find this book if this library will be so big. However, if you manage the shelves and the way you are going to make this warehousing for the books, that said, okay, this zone is for science, this zone is for literature, this zone for history. And then you will give special index for each book, and then put books that they are within the same subdomain, under the same big topic, in the same place. It will be easier to you to retrieve any book later. So pre-planning how you are going to store, going to warehouse, and where you are going to put each book based on a map that you are going to construct to library and make different zones. And sometimes maybe you may make different restriction, or you said, okay, normally all science books should be in the same place, because who will come here? There are special people interested for this. I will not put math with literature. I will put math with physics books here. So this way will help you so much later to retrieve data and to make different reporting, whatever it is. The same scenario here. If I have an information system, I know now about the different users and the functionality. However, I have to make analysis and the design about the database or the data storage, how it will be. So if you remember the part concerning the SDLC cycles that we said, the planning, analysis, design, implementation, and maintenance. the data modeling will go from each part from this phase. Now we are in the analysis. Here, we will go to something we name it conceptual data modeling. I don't know if you have already taken a database course or still not yet. So maybe you will be somehow familiar what we are going to talk about it now concerning conceptual data modeling, which means that here on this level, I will not talk about how to implement this database management system. If I go to the example of the library, I will not put the shelves down. Just I have to study what different topics I have and what is the relationship between these topics. The same here. We said conceptual because at this level in the analysis phase where we are, we have to know how many concepts or topics or objects that they have characteristics, because in order to say this concept, I'm going to store a data for this, it should have different parameter characteristics that we are going to create different tables later in the database for this. So here we have to study how many concepts we will have, and what is the relationship between these different concepts. Remember this word. So we are going to construct an entity relational diagram based on entity relational model. Entity, we will talk about it. We are talking about concept. Relational, what is the relationship between them? And they are a relationship between because different characteristics will make a one entity or will make an entity type, because they share common, they talking about the same topic, so there is a relationship. And these entity types will have a relationship between each other. So we have to finish today the analysis part, and we will have an ER diagram, a conceptual analysis diagram for what is different concepts that we are going to save data for them, and what is the relationship. And again, when we talk about analysis and design, always we have to talk that the delivery, the outcome of each phase or a sub-phase should have a special format. Always remember what I said always about a civil engineer or architecture engineer, that this person, this engineer, when he is going to sketch a map, he can't have his own abbreviation. He has to sketch this map based on a special standard. The same for us. If we are going to sketch different diagrams, that these diagrams will talk about the outcome of this phase or this sub-phase, so it should be based on a special format. So today we are going to talk about this conceptual data modeling first, then we are going to talk about ER model and diagram, and then we will talk about some special cases when with this entity types, we will have subtypes and supertypes. It is part of a hierarchy, we'll talk about it. And we will finish with sum up what the business rule we will have it here, which is 4 basic business rules that we are going to talk about it. So let's start about, I have already discussed this, but let's go more about it. What do we mean by conceptual data modeling? So again, don't forget that we are here. Today we will finish here. And next lecture we will start here. So this was done in the last lecture. And today we will continue. We have started this. The last lecture also, we finished the use case model that give us about different users and their interaction with the program. Today we will talk about the sub-phase data modeling. So conceptual model, based on our different interviews and group interviews or using modern ways that we have already done, a requirement we have already collecting. So now, don't be mixed between users or actors as they interact. They are part from the real world, by the way, and maybe you will have more. So the users and the use case models that you talk about, for example, when you talk about the restaurant, we said that we have the waiter and we will have the receptionist. They are real world concepts and the actors. They can be part from here, from the conceptual model, but there are more real worlds that we have to deal with. Like the restaurant itself, because there are some data. So the real worlds that based on different discussions that we have it during collecting requirement, now we know what is the different real world concepts that we will have. So we will go this conceptual model. Sorry, and then we will have a logical model. This is here, this and this. We'll see it in the design phase. Some people maybe will say the conceptual model, they will do it as apart from the design. Based on our definition using this SDLC cycle, it is part from analysis. So if you go online and read some references, again, there are some references will see that this conceptual model, it's not part from the analysis, it's part from design. Me, no, I believe it is part from the analysis, because we are analysis, you are make this structuring in a very higher level, which means that you don't go deeply to start more digging deeply when we go to design. So for us, the ER diagram will be in the analysis part, and the logical model, what I mean by the logical model, it is that after we have this ER diagram, which means the different entities, at this level, we will not say they are tables. We said it is entity, that a concept that has special characteristics and parameters. In the design, we are going to transfer this ER diagram that we have already agreed here in this level and make something, we name it database schema. Then the entity will be not anymore an entity, will be a table. And then when we go to the implementation, we write the DDL query, we will see it then we will have a physical file for this table. So I said, this is what we have already discussed before, that either we are going to develop data model for the current system, if we have the system. If not, then just we take, and then develop or purchase a new conceptual data model based on the requirements of why is this system and the new system, to see if there is a mapping, if I have an existing system. Because the new system, maybe sometimes it is an update for the old one. So this depends. But in our case, we are doing a new system. So we will go to this step. And during the design, as I have already said, we are going to match this to a database schema, and then we implemented it to have a physical file. Sure, the project repository, which means that project repository, the platform, the framework that are going to use in this project for the cycle, will make the different links for this. This is what we are doing in this course. The output for the first phase, it will be second one based on special format, and all data is being collected in the same way, in the same place in this case. Here. So this is summarize what I have already mentioned so far. We finished the planning. We start with the analysis. We are here in the second subphase of the analysis. This will be our outcome today. This is an ER diagram. I'm talking about it. And then this ER diagram, we are going to do it as a database schema, relation database schema, that we will have table, and then we will have different attributes for this. And then in the implementation, we are going to write what we name it DDL query. In SQL query, again, I don't know if most of you, they have already finished database course, yes, no. By the way, who has finished database course, who is now with us here? If somebody has finished database course, just make a thumbs up. So Andrew, Kevin, what about the others? So just Andrew and Kevin, Myson, that you have already finished also database. So the others mean that they haven't finished the database course, so they are not so much familiar with this in this case.
Hello?
Yeah, hello, Kevin.
Hey, so you mean database like Java and stuff, right?
No, database about database system. When you learn about how you create tables and SQL queries and you make inserts, select, update queries. This is what I'm talking about database system.
Okay, then I haven't taken the course yet.
Yeah, there is a course. It depends on which program you are. But if you are going to be in the BS program, and I think also in the diploma program, I'm quite sure you are going to take the database course. In the database course, you are going to learn how you write queries, because you are going to learn SQL language query. It is a special language. It is like, for example, we have a higher level language. You have already learned C++, Java to write a program. There is a query to create a database and deal with database management system.
Okay, got it. Thank you.
I'm checking the course right now.
Sorry?
I'm checking the course right now. It's computer 230.
Yeah, perfect. This will be somehow help here, because in the database course, you will go more to here to learn more about how you write a query and to create this table and make this physical file. You are going to deal with a database management system, either MySQL or like Microsoft SQL Server. So you are going to write to, but this will happen based on in this planning, analysis, and design, because I should know about to reach this point. I should finish this, then finish this, then go here. So as the implementation part, I will write a DDL query. DDL query mean the query in general, the SQL query. You shouldn't be confused between SQL query and database management system. We have, for example, Microsoft SQL, we have MySQL, we have NoSQL, we have a Firebase, which means that it's also talked about real-time database management system that is being used by Google and Android-based. So we will have different database management system. Most of them, they accept or deal with SQL query language. Why we name it? It is out of the scope of this lecture, but it's good that you know about it. Why we name it SQL? Because it's query, because it's based, you send a query to the server and you expect to have an output. So the query, it will be under two categories, the queries. Either DDL or DML. DDL, which means that data definition language, it is the query that you are going to use here after you have this schema. It is data definition, which means to create tables, and each table will be a one file physically in the server. And there is another type of queries, we name it DML, data manipulate language. It is more a query that it's going to insert data, select data, update data, delete data. So in this queries, you are going to learn it in the database in the database course, and you are going to deal with special database management system. Where we are now here, so we are in a very higher level. This is why I believe it should be the analysis, not in the design. Some references, they will put it in the design level. Because here we talk what is the different concepts and what is this parameter for these concepts and how they are related to each other. In the design, we will go deeply till we reach the implementation, and sure, in the last phase, we will make evaluation for this data model and to see if maybe this structure of this database needed to be updated. Maybe we will add new tables later. So this is the data model for us, how it's going to be updated based on different phases. This is a sample. I will not discuss it now because I will discuss it during the lecture, just to know what I'm talking about, conceptual data model. This is a sample for ER diagram. We said ER model and ER model diagram. Like the same when we talk about use cases. We said there is use cases. We name the use case. When we talk about the restaurant, we said, okay, reservation is the name of the use case, and there will be a scenario, and then we will have a diagram. The same here. we have a ER model diagram. We have the ER model. We'll talk about what is the entity and entity types we will have it and different characteristics for them. And later we will talk about and start sketching this diagram. So this is a sample conceptual data model diagram in this case. Yeah, gathering information for conceptual data model based on what we have already done. It can be the same what we have already talked about, top-down, bottom-up approach. So either you will this should be done while we make the requirement gathering, because we have already collected this as a part from the whole requirements that we have already gathered. Let's start with the ER diagram, which is the main point that we are going to discuss. This how we are going to do it. Entity relational ship or relationship data model, or you can say entity relationship data model diagram. To simplify it, you can say entity relational diagram. So, but it is entity relational data model diagram. We will have entities, relationships, and attributes. Okay. So what is the main difference between entities and entity type and entity instance? It is the same if we take the concept of person. Sometimes you will be mixed. I'm talking about object and classes. No, we're talking about a concept. It is because a concept can be a class and it can be something that we are going to store in this case. So we are talking here about the entity or the concept that we need to store data about it. So here, for example, if we talk about entity, it can be a person, can be a place, it can be an object, it can be an event, whatever it is. And an entity type is a collection of a special collection from this entity that they share the same properties. Like here said, person, it is an entity. However, employee, they are a special type of this entity that share a special characteristics or properties. So this is why we say entity type. And normally when you are going to write the entity diagram, we are going to talk and about special entity types. Different entity types, we have it here. Entity instance, like it will be an instance from this, which means that in our later it will be a row in the table, which means that suppose that we are talking about a company, we are making an information system like for a factory that we have this example before. So the employee entity, it will be an entity type because this employee, you are going to store data for them, and we are going to have different the employee ID, date of birth, name, their job description, and each row will talk about special employee, a special instance. So here at the ER diagram level, we talk about entity type. The instance, we will see it later when we are going to enter data. Each row in the table will be an instance for this entity type. And with the entity, I said it is the wider concepts about person. But when we talk about the AR diagram, we have to talk about different entity types we will have it. Again, now we will see this different notation that we are going to see it. Don't forget that this different notations that we will have it here, the way that you have to use a notation, it is a standard. You don't have your own standard. So if you are following the standard, you have to stay with the standard. You can, for example, for an entity type, it should be like this rectangle. This is a normal entity, or we name it a string. You can't have, for example, a triangle for this. You can't. It should be like this. So we will see it. I will not discuss it so much here because we will see it later. So just you should know you have different entities. So entity we will have a rectangle. Either entity will be strong or weak. We'll talk about it, what do you mean, or associative. Here we'll have different attribute. Also, the attribute can be optional attribute or can be derived, which must come from another entity. Can be multi-value. and can be composite, and each, or can be a normal entity, or like here identifier, which is a key in this case. So we have to sort all the entities, and for each special type of entity, we will use a special notation, like using special braces based on what this entity type, or sorry, attribute type, based on the attribute types that we are going to define for this attribute in this case. Let's go more about, all of this we'll explain it as a brainy set, so we'll explain more during the lecture. So let's start with the entity types now. We said entity type should have first a singular noun. We don't say employees. Employee. Descriptive. The name you are going to choose it should be somehow descriptive. Because again, this ER diagram, maybe you are with you as software analysis and design. You will make the analysis. Another colleague in your company, you're going to make the design. So we will not expect that all people will do the same job. So this is the life cycle. Each phase of it, maybe somebody else will do it. So this is why you should take care that when you are going to create this ER diagram, to use a name that's very descriptive about this entity type, so anyone can go to check your diagram and read different information is being included, can understand it in a better way. Concise, sure. Which means be very specific in this case and doesn't go to use very generalized names for this. And the name somehow will be very specific, that it not be ambiguous and make some confusing when later anybody is going to read this. So an entity, as I said, this is a strong one. The main difference between strong and weak. If it is weak, it will be like this. We will use a double line border. And the entity type, it is as strong. This is a normal entity, like employee course, which means that it has different properties and you can create a key for it or identifier for it. For what I mean by a key, for example, if here the employee, a key, we will talk about it also later. A key is an attribute or set of attributes that will be unique. Why we need to have a unique attribute when we are going to build our ER diagram, and for each entity type, we should have a key or identifier. When you registered in the university, the first step, the university to create a file for you will give you an ID. If you are not an ID, that means if you don't have an ID, then you are not a student in the university. And you are not registered in the system. Why is ID? Because later when we going to retrieve any data for you, we can just write your ID and send a query and get the data from the system. Again, then we're proposing this diagram, and then we are going to make the design and implementation. And we expect, as I said before at the beginning, the library example that I give it to you, that during this, when you are going to retrieve later a book from the library, it should have, after you make a good management for different shelves, each book should have an index to pick it up. Sometimes if you are going to, we will not have an employee ID. Kevin, for example, come to me and said, okay, Gibbs, I want to see my courses registered in the system. So if I write Kevin, I will have hundreds of students named Kevin, and sometimes the first name and the last name would be the same. Sometimes the first and the middle and the last name would be the same. So there is nothing will be unique identifier that identify the file for this student. So you have two choices. Either we create an artificial one, like the same what happened here, that the university will give you an ID that it is an artificial. Before you be a student, you don't have this ID. So it is a characteristic that our property that was created for you by the system in order to have a unique identification for you. So a strong entity, it is an entity that will have identifier, or we can choose an identifier. When I said identifier, it can be one attribute or more. Doesn't mean that should be only one attribute. That we can choose identifier based on different attributes that we will have. A weak entity, it is an entity that we can't have identifier from the attributes that it has. We need to have more attributes from other entity to get or create identifier for it. Maybe it is not mentioned in the lecture, but let me give you an example about weak and strong. It's good that you can understand this. Suppose that we will have player and team. This is player and this is team. You have a team, for example, there is different team, like whatever it is. I'm not so well with the sport, so maybe I follow up the European League. So I am football game watcher, not so much other games watcher. So suppose that we will have an X team. The name was name of X. And here we'll have name for the player John, for example. This is name. And you have a date of birth, whatever it is. So, we creating a database for all the employees and teams in the world, not in a special country. So John play in the team X. However, there is no global identifier for the whole players or artificial identifier like for the whole players in the whole world. For example, suppose that FIFA will not give an ID just for the national team, maybe for the whole teams, the whole world. I'm not talking about only national, I'll also talk about the local teams. So we will not have a special unique ID for each player because there is no an organization, global one, that give an ID for the whole players in the whole world. It's not like the university. The university management or administration will create an ID for the whole student for this university. However, we are talking about the whole players, the whole teams, the whole world. We are creating an ER diagram for this database. So if I want in the table for the table player, I will have the name of the player and date of birth, maybe the address, maybe whatever it is, and the number, because this John play in X, it has a number, not ID. You know that player can have 1, 2, 3, 4. So John is the number of team. We have number X, number 10 in team X. So all the parameters here I can't have identifier because name and date of birth, maybe name and date of birth, it can be, we're talking about the whole humanity. So maybe it has the two names with the same date of birth. It can happen. It is not easy to happen, but it can happen. Name, address, I don't know. So in this case, there is no group of attributes here that can make an identity, and I don't have the way to make artificial ID. So we said it is a weak entity. How I can solve this? If I will get here the team name as an attribute here, I said, okay, team X player 10. So this is a unique identifier because we will not have in the same team more than two players with the same number. So a weak entity that we can't create identifier for it using standing alone attribute. So here we will have now here strong entities. Attributes, we have already attributes characteristics. What different attribute we will have? For example, employee, we'll have employee ID, we'll have employee name, birth date. So we will put here, we will have a course title, course ID. We will talk now about that, what it means by this underline. You know these braces? You remember here what I said here? That the braces would mean that we have a multi-valued that in the same, for the same row later, we will have different values in this case. For example, when we talk about course, I said course ID CIS 270, or maybe you're talking about here. Yeah, we can say course 270 ID this, title, analysis, and design. When we talk about topic, I said analysis, object-oriented, UML. I said it is about ER. So different topics will be for this course in the same line. So we will have a multi-value. In this case, if you expect this attribute, we will have for the same line, for the same entity instance, we will have different value. So we have to put braces because it is a multi-value attribute in this case. Yeah, we said this is, yeah, sorry. So when we are going the same, when we talk about the entity name, the entity type name, that choosing the name is very important to be more descriptive, more specific, more precise. And also, as we did here, that if it is multi-value, to use a special notation for this. If it is derived, which means come like the case when we have a weak entity, or sometimes you will have, because of this relationship, we will see it more when we go to the design. You will get a copy from the identifier of a table or an entity, put it another one to make this relationship. We will talk about it later. So if there is special, like I said, special type for this attribute or from where it comes, you are going all to describe it here within the attribute, as I did here. Okay, now what about keys and identifier that we talked about? It is a must always to have an identifier in a table. And if it is a weak, you have to solve it by getting a copy from another attribute, from another table, put it in this table to create identifier. Because without identifier, I can't later retrieve a data for a specific entity instance. So here in this case, we will have the identifier is employee ID. And we can say it is first, we will have different candidate key. What mean by candidate key? A candidate key, it's from the word candidate, that you will have more than one choice to have them identifier. So either you will have an employee ID, or sometimes you will have the employee name and date of birth. Both of them, you can say this is identifier, because in the same company, you will not have the same name, the same date of birth. So in this case, so you have two choices. Either you choose an employee ID as an identifier, or you choose the employee name and date of birth as identifier. So the candidate that they are a candidate to be identifier. So candidate key, you will have more than one choices. The identifier is the one that you have chosen to be the final identifier for this table or this entity type. You should be sure when you choose identifier from different candidates that should be had a unique, unchangeable, which means that because if it is somehow changed later, because this entity relation diagram is somehow there is a relation with each other, which means that later when you create an employee and the entity type project, and this project is done by this employee ID, And then if this employee ID will be changed for the same person, then sometimes the data will be, you will have some corruption in the data because this is what relates to employee ID who is Ismail, and now this employee ID doesn't include it to Ismail. So this is why when you choose identifier, the same like you have an identifier, a special ID. If you finish from the university, and sure, I will be happy to see you graduated. So you finished from the university and you have already graduated. Your ID will not be given to another student. Will never. So because if the same ID will be given for another student, in this case, there will be some overlap between different files for the students. So if you have different candidate key, choose the one that you believe that it is unchangeable. And for sure to be unique and null. There's no duplication. You can't have two students have the same ID. Avoid using intelligent key. Intelligent key means intelligent or artificial keys. That if you can use one of the existing key as from existing attribute or candidate key as an identifier, go ahead and do it. Rather than creating a new. In our case, we have to use an artificial key when you go to university because there is no other choices rather than creating our own artificial ID for the student. And we are going to give different composite, which means maybe some I don't know your ID how it looks, but normally all university when they have to go to their ID, some digit will talk about the year you are, the year that the first year registered. Each school will have special digit from this whole ID. The same like social security number in Canada, for example, you will the first maybe one number or two numbers social talk about the province that where you registered or you were born. So the same here when you create your identifier ID, you sometimes it will not be easy to manage it. You should have a special standard about how you are going to create this key. However, if you can choose one of the existing attributes, it is better in this case. But if not, then you can create it, go ahead and do it. It's better and avoid having weak entity. Maybe I didn't mention this in the lecture, but for you who is listening now and later who is going to see this lecture, it is a bad design later if we see some weak entity. Weak entities, we have to go with it if we don't have any other choices. So avoid as much as you can weak entities and should have most, but if we have to do it, we have to do it. But for us, me as a consultant, if I have an ER diagram and find that there is so much weak entities, I will say it is a weak ER diagram. So avoid as much as you can weak entities and try your best that you will have more strong entities when you are creating or sketching your ER diagram. Other types. So we said we have other types like multi-value attribute. And multi-value attribute for sure that maybe here we said there's here. We said this is here. We have a multi-value attribute. And sometimes you will have a composite, not a multi-valued only. Which means that here's this composite attribute. Means that, for example, address. Address will have a street name, city, postcode, house number. So there are this attribute, which is the address, because as an employee ID, as an employee table, you will have an address, but this address, it has different, let's say, sub attributes. Later, maybe you are going to create an entity type for this address. We will do it in the design level in this case. In the analysis level, we can say it is a composite attribute. It has different sub attributes. And you, again, don't forget that as here, I mentioned here, that each one, like here, this composite, we will have like this, multi-value like this, derived like this. So we will have each one like here. So it is an optional, and this is a must to have it. But optional, which means that you should have it. But it is a must. Maybe not linear, no, it is a must. Sometimes we will have an optional, sorry, not a must. We have to say that it is an optional one. The employee name here, it is a must to have it. Optional, which means that later, when you will ask data entry, you say it is optional. You don't have to, for example, you will have you will have 2 phone numbers for an employee. You can say the first one is a primary to have it, or it is a must to have it, and the second one is optional. So later in the design and later in the implementation, you will not enforce that the user will enter this data. So all this attribute, when we are going here to put the attribute, if there is a special type of attribute, we have to mention this here. Again, we have to mention this here. Like we did here, we did here, we did here this line, talking that this is identifier. So now the last part here, it is the most important part, is about relationship. About relationship, sorry. Relationship, we here talking about, okay, now we have this entity. Do you want to have a break or I can continue? We are almost now 1 hour now. If you want me to continue, I need almost more 20, 25 minutes or 30 minutes. And maybe if you make a practice one exercise, we will take more time. So if you want me to continue, I need 3 thumbs up. Sorry. No. Yeah, go ahead. If you want to continue, 3 thumbs up, I will continue. Or stop for a break. So Kevin want me to continue. My son want me to continue. And Shannon want me to continue. Shane want me to continue. So I will continue. So the employee, we have already for this employee and this course 2 entities, strong entity. We give it the name for this entity type. And also we have already declared different attribute here. And after we have already declared different attribute and giving different types and identify who's the identifier based on different candidates, we finish all this. We finish the attribute and the entity type name. However, the most important part now about the relationship, because this relationship tell me about this different entity type, how they are related to each other. The same when we talked about use cases, we defined different actors, but the most one was about the functionality and the overlap between this functionality. And here, because most of the business information system, most of them, then we talk about a relational database. Why relational database? Because later, when any action will be done in the information system, hear this word, it will be a transaction. A transaction means that different entity type will be affected at the same place. Give you an example. You are creating an ERP system or accounting system, and it's being used by a firm or an organization or a company. When the cashier, for example, you go to Superstore, to Walmart, whatever it is, the cashier there, when he has to scan this, there's many entity type or tables will be affected by this scanning. First, a new bill should be created. Second, each product is being scanned should be diminished from the stock table. Third, this employee who's making this action, because maybe I will give some commission or some bonus for different employee. I should know this. The table of the employee, I have to talk with about it to get the name of the employee. So employee table, warehouse, billing, and maybe customer if I want to add a name. So different entity type, they will be affected by this action. So I should know about the relationship, and later when I will make different action in the system to know what is the different entity type will be affected by this relationship. by this transaction. This is why it is very important that we are, most of the business information system, they are going to be a relational database model. There are different database model or entity relational model, but in our case we use an entity relational model because we expect this database system will be a relational database later. So we will have a relationship, and this relationship we will give it a name. Again, we will have a relationship, and this relationship we will give it a name. Like here, an employee completes course. So which means that I'm not talking about university or school, I'm talking about employees that making training courses. So this employee is going to, this is here, you see this sign? It has a meaning, many, which means that this is a many-to-many relationship. What does I mean by many-to-many relationship? That the same employee can do different courses, not only one course. In this case, here this word, a one entity instance, like Chen, it is an entity instance from employee, can be related to different instances from the other entity in this case, like C++ and Java, they are instances of this course in this case. So when I said many from this part, which means that one instance from here can be related to different instance, like here. One instance can be related to different instance. When I write many from here, the same instance can be related to different instance from here, because this course also can be taken by different employees. Here, mentioning here about multiplicity that's taking place is very important. It let me later understand more about my database schema, how it will be. And this is many-to-many relationships. When I will transfer in the design level the ER diagram to a database schema, maybe I'm going to create a new table between of them. Keep it to next lecture. So when I talk about a relationship, first, give it a name. Second, I have more for this name. I have to give it also the multiplicity about how the relationship will be between these two entity types. So before we go about here, let's first see that what different degree of relationship we will have. First, either we'll have a binary relationship. Binary relationship, which means that a relationship between two entity types, like here, employee, parking, product, student, course. Or you can have a unary relationship, which means the relationship with the entity type itself. Like person, you have all the information for persons, and some maybe it's two persons, man or woman, or whatever it is, they can be in the same is married to, or in this table in this case. Employee, manage, that this employee table will have the name of the director, will have the name of unit managers, all they have in the same table. So one of them will manage the part of them. So sometimes we will have a unary relationship. This unary relationship will have, let's say that with the same entity type as we mentioned here. The last one is ternary relationship. Ternary relationship, that a relationship between more than two entity types, like here, it is between three. I will talk about it now, and later I'll talk more about this, but let's first talk about this. So we will have here many-to-many relationship between three entities type, vendor, part, warehouse. A vendor will supply different part for this warehouse. So this is relationship between, why is this? This is not later, maybe we can create something we named associative entity type. However, this is because there are some attributes that they are related to the relationship, not to one of the entity type. Shipping mode. Vendor will give this part or this product to this warehouse, but each time he is going to supply, which means each time he has to make this action, will have a special shipping mode based in a predefined or an agreed shipping mode. So I can't put this attribute here because it's not related to the vendor. I can't put it here to the part, it's not related to the part of the product. I can't put it in the warehouse, not related to this. It is related to the relationship itself. However, the relationship, it is not an entity to have it an attribute for this. So this is why I put this dash lines. Maybe I will create an entity, I will name it associative, but we will talk about it later. So when we see this sign, which means that we will have and using this sign, we will have this attribute related to this relationship. Let's talk now about what you have already discussed, this cardinality, or another word for this, multiplicity for the relationship. Here we discuss the different degree. Now about the cardinality, which means that we discussed part of it as a beginning. Here we have different symbols. You have to know the symbols and to use them. This symbol, it is about many. This symbol about optional. However, you can see that there are sometimes optional will be many or one. Here will be many optional, and if it is one optional, we will use 2 lines in this case. Let's take example. Patient and patient history. Here we will have a mandatory and optional. Here we have a mandatory here. Why mandatory? There's no patient without a patient history. So I can say this is a patient in our hospital or our clinic and he never been here. It never happened. So in order to be a patient, he should have a patient history. Okay. So don't forget this is mandatory many and this is mandatory one, which means that a patient, it is mandatory, it is not optional. This is why we use this. But he can have 1 visit or more. This is why we said it is a mandatory many. If it is not mandatory, we will not use this sign. We just use many. Many means it can happen. And if it happen, it can happen many times. When I said many, one, or mandatory, which one many, which are mandatory. In this case, mandatory, again, it is a mandatory. In this case, it is must to happen at least one. Again, if I have used this, only this side, which means that logic, patient, in order to be patient, should have a patient, should have a history, which means has a visit. So, and when he has a visit, it can have more one visit by time. So it should have at least one and many. This is why I use this to use that it is a mandatory, should have at least one, and it can be more than one. Here, I said at least one and only one. Mandatory one. Why? Because each visit will be for a patient. It can be for the 2 patients. Even though, for example, one family come, father and a child, wife and a man. So in this case, what will happen, that when they will come, each one will register his own visit. So Using this sign, tell me that it is mandatory. Using this double sign, tell me it should be at least an exact one. Using this, tell me it is a mandatory. Using this with this, tell me it should be at least one, but can be more. Another example. Sorry. Here, we can see that having optional and many. Even we can see here mandatory and many. The same what we have seen before. Let's see why. An employee is assigned to a project. So an employee can have a project or can't have a project. Maybe he is more administrative and he is not related to a special project. So an employee can be assigned to a project or cannot, and can be assigned for many projects. So it is optional many, either 0 or can be 1 or many. This is why we use optional many. An employee is assigned to optional and many projects. A project includes one employee or more. I can say there is a project without employees, and it is not a project. So it should be at least one and many. This is why I use this sign. Should be at least one and do. Here, when I use it, should be at least one and at most one. Here, we said this is optional. So person. So 2 persons can be married or cannot be married. So I said here, if this happens, it should be at most one. You can't have the same person married for both. It depends on different society, but let's talk about, so it should have one person married to another person in this case. And this person can be not married. So this is why we said it is optional, but however, at most one will be in this case. So we use those. One optional in this case. This is we have already seen before, and I have already discussed with you, that sometimes we will have a relationship with an attribute. And this relationship, with this attribute, sorry, it will be not related to one of them. This relationship will be related, this attribute will be related to the relationship. An employee has employee ID and employee name, and this employee name is composite. This is why we write it here like this, which means that first name, second name, last name, it is birth of date. Here we said that we make this because it is a multi-value attribute. It can be different topic as for the same entity instance. So date completed. Date completed, it is not an attribute for employee, it's not attribute for course. This attribute happens when this relationship is satisfied. When this employee completed this course. So this attribute is somehow related to the relationship itself. This is why I put this dash line, to tell that it is not an entity, it is an attribute or set of attributes that they are related to the relationship itself, not to one of the entity types that I have. However, it's better to do it like this. I'm not with doing like this, because even though you do it here in the analysis like this, later when you are going to make a design, especially when you will have a many-to-many relationship, especially when you have many-to-many relationship, you are going to create an entity to this. So it's better now to do it like in especially when you have a many-to-many relationship. Again, we have a many-to-many relationship. Like here, we will have a many-to-many relationship. And we said optional many because when I said optional, maybe it can happen or not. And if it happened, it can maybe happen different times. I know there's so much notations that we are telling here, but I'm quite sure it will be easier. And again, when you revise the lecture, and I can know that you are one of the benefits from the YouTube that give me the number of the viewers. I can see that, I know that student will go at the middle of the semester, they will have the midterm. However, I can see that the number of the viewers is now decreasing. So take care, this course is sequential. It has different, let's say, entities, phases, it's related to each other. Do your best when you dealing with this course, not to weekly based study it or revise it, to keep the track of this course in your mind. For example, if you will not revise now the entity relation diagram this week, I will do my best. I will give you an assignment now to practice the analysis phase, because we finished the analysis phase, so we can have an assignment for the analysis phase. So, however, if you don't practice it now, when I will start with a design based on this, you will be somehow confused or missed what this guy is talking about. So this is why do your best, just keep tracking, which means that weekly base, go ahead and give 2, 3, 4 hours. No, I think you need 3, 4 hours weekly base for this course, and practice some exercises to keep the track of the course in your mind. And again, as I said at the beginning of the lecture, I will be very happy to receive your emails, and I will be happy to host you in a virtual office hour or at my office at Chilwa campus if you have some question concerning the course. So don't be hesitated or shy. If you have any question, go ahead and drop email or ask for a specific time to answer your question. It's better if you have a question now, ask me now. I'm not talking about the lecture now at this stage, in order not later you will be lost, or somehow you can see that you are not understanding what's taking place. So an advice from your coach, do it weekly based. It is somehow interesting course. Some student I read in the internet that sometimes they said how it is somehow, maybe the way we are going to give the course depend about how it will be interesting, yes, no. I'm doing my best to do it more practical. This is why sometimes I have to get some topics outside of the box to include it in the lectures, to give it more practical oriented. So again, do your best to do it weekly based. So we can have an associative entity, that creating an entity for the attributes that are related to the relationship. And then it will be a middle entity, which means that entity type here, they are related to each other directly. Now they will be related to each other indirectly. This related to this and this related to this, like here, certificate. Because each course, by the end, if you make a training course, you get a certificate. So an employee will have a certification or certified by this course. For me, it's just better when we will have many to many, because if we didn't do it here, we will do it in later stage. Associative entity. When we have a ternary relationship, you should take care about the cardinality. We have already discussed this, because the cardinality will affect the whole sequence. Like here, we will have 1, 2, 3, which means that again here, mandatory 1, optional many. Here we will have mandatory many, When I said optional, it can happen, it can happen, it cannot. And here, because maybe he was going to give supply and he give not, so he will not fulfill the order. But however, if this order happen, it is a must to have a warehouse where it go, and it is a must to have a part, at least one product, at least one warehouse, if this happen. However, not always vendor will supply what the warehouse or the company will ask for as a purchase request. So the same that we have to done when we have a buy one, the trainer will talk about different types. This is why if you have a ternary relationship and you have an attribute for this, here this is, yeah, I think we have already done this. Yeah, here we have the attribute for this. And ternary one, it's also better to create an associative entity for it also. So if we will have an attribute that are related to a relationship and we have many-to-many, it's better to have an associative entity. And if we will have a ternary, which means that you will have more than one entity type related to it, it's also better to have an associative entity for this. So we are done with, I talk more now about, we are still small parts we have to discuss in the lecture. However, we are done from the ER diagram so far. So we talked about the entity types, we talked about the attribute, different types of the attribute, we talked about the relationship, different degree in the relationship, and cardinality or multiplicity. Some people, they name it multiplicity, some people, they name it cardinality. And we talk about this cardinality or multiplicity, how it will be, and different notations. And again, this is a standard notation. You can't change it. You can't have your own notation. There are some other references, they will have another notation. For example, they will not use this. They will use something like this. Some people, they will not use this. They will use 0, 1. But we are stuck to this notation. So if you use a special standard, you have to follow it up. So the standards that we are using in this course, we have to follow up in all our different deliverables that we are going to deliver later. I want to discuss more about subtypes and types entity. We said we have entity types. We said we have strong entity type, we have an associative entity, and we have a weak entity. Sometimes we will have subtype and type. People who talk about OOP will talk about that we have a class and subclasses in this case. I'm not talking about class and object, which mean an entity type and entity instance. I'm talking about classes and subclasses, because we are talking here about entity types, not talking about classes and objects. So we said we will have an entity type and we will have entity subtypes in this case. So the entity subtypes that we will have it here. Sometimes like patient, you will have two types of patient, outpatient and a resident patient. As you know from before this class and subclass, which means that when I said outpatient, I write only this attribute. Does it mean that he has this attribute only? He has all this attribute plus this attribute. Why I have to have subtype? Because suppose that I didn't do this, and I add here check back or date discharged, let's say date discharged. Date discharged here. And now I'm including the name of a patient who is not an inpatient, which means it's outpatient. You know what is mean by inpatient, outpatient. So an inpatient is a patient that he's going to stay at the hospital. Outpatient, he makes some lab tests and then he will go out and go to the clinic, so he will not stay as a patient. So if I'm making later a table and I go for X, this patient ID, in the outpatient attribute, it will be null. Because this attribute doesn't match with his situation. He's inpatient, he's not an inpatient. So if I make the structure like this, which puts them all in one table, in one entity type, in this case, when I go to this, I put null. This is make we name it redundancy in the database. Why I said redundancy? Because at the end, this is storage. You are going to have a physical files, and you are going to store them using a physical storage. So you are storing null data. Null at the end, it is a data, null. So we are using part from your memory for null data. And so suppose that you have a huge records. So null, many nulls. So it is redundant. You are wasting your memory storage. This is why if you believe that there are some attributes that are related to a special type, so in this case, go ahead and create a resident patient and make this date discharge. In this case, the resident patient later, when I will make a table for them, a physical file, it will include all this plus this. But here I am the conceptual in the analysis. I will make this notation between them, telling that this entity type, it is a subtype from this. It includes all the attribute of the super type, of the super entity, plus a special attribute for it. But this is a standing alone entity, and this is a standing alone entity. However, it inherits all the attributes from the super one. Yeah, we said this is we have to talk about the overlap role. This depends on the business roles that we have it. And specialization role, which means that this will be special for this, not include this. We have already said this. This is another example about, for example, when I have table for employee, then I have, okay, all employee will have a salary, all employee will have a date hired, but like in our university, we have a faculty and staff. And this faculty and staff, we will have a rank and position. So it depends, this is a position, because for example, we as the university instructor, we will have some, we name it academic rank, assistant, associate professor, whatever, full professor. This will not be, this will not work with the staff. Staff will have a position, not academic rank. So this attribute, it's only for faculty employees. This is why I have to make it a standing alone subtype for this in this case, in order not to have a redundancy in the data. So now I have something to share that, yeah, if I put here this rank, as I said before, put it here and doesn't have a faculty one or staff one, put rank and position here. Yeah, it is not, will not give me, let's say, a bad result. However, you always have to see what is effective and what is the best to do it. So here in the analysis and design, you should put all the different, let's say, characteristics or different specification you will have it in order to have the best design later. The same when you write implementation and code. The same code you can write in different way. But when we go to the, I think you should, who is going to take, to finish the BS program, they should take something we name it algorithm and data structure course. In this course, you are going to learn about complexity of algorithms, which means that when talk about complexity, which means the efficiency, how complex it is. Less complexity, it is a better algorithm, even though all of them, they will give you the same outcome. But this algorithm will waste your temporal memory or your RAM more compared to other one. And sometimes if you have a huge data, it will freeze in this case. Like what we always hate in Windows, freezing. So the last part for today is about business rules. So business rule, we have to specification to preserve the integrity, which means that we have already done part of this. This two part, we have already done it. Entity integrity and referential integrity. Entity integrity, because we talk about what is the unique attributes that we will have it. Do you have a question, Kevin?
Yeah, on your last slide, I didn't know what the D stand for.
Here?
Yeah, like
Can you
employee
repeat
and then faculty and then staff. There's a D in the middle.
Yeah. Sorry?
There's the letter D in the middle. I didn't know what it was.
Yes, this is because talking about we are doing different sub-level because we have a hierarchy, different level.
So it's just a name, right?
Yeah, because you, for example, you have this is a first level, and then you have another level, and you have a third level, and so it's just because of the leveling that we will have it.
Okay.
We will have different sub-level in this case.
Okay.
Here,
And then what's?
Yeah, so here you will have. Do you see here? You have a one level, and then we will go here to have more level, which means that like disjoint overlap. Here, disjoint D come from here, disjoint. We will have here, for example, O from overlap.
Okay.
So this is come from the business rules that we have already talked about it.
Okay.
You are okay?
Yeah, got it.
Perfect. So we were talking about entity integrity and referential integrity. Entity integrity, we talk about, I said we have already done this, that when we have already talked about the entity types, we define a special set of attribute or one attribute, we name it as an identifier to have this uniqueness, and we said it should not be null. And we talk about referential integrity constraint when we talk about the relationship type. We said this relationship should be many to many, one to many, or it should be at least most or one or at most one. We have already talked about the two power types. The domain where when we put the entity types, sorry, the attribute, we didn't talk about the domain. Now, the domain, people, they're more, let's say there's more references in it. Some references will say that we have to mention the domain name in the ER diagram. Some will said, no, we can mention the design later. Me, I believe that maybe we can mention the design because and at the conceptual level, I should know what is the attribute and what is the relationship to, what is the attribute name and who is the identifier and what is the relationship and if there is a hierarchy between them. The domain name is talk about the type, not type of the attribute, meaning that if it is multi-value, no, this is not the means of domain. The domain, it means that the type of the value of this attribute, like integer, double, string. So some of the references we said that it should be included in the ER diagram, some references which will be included in the design level. Both are correct. I will be more oriented to include the domain in the design diagrams. Because in the ER diagram, we will be more, that for us at this level, as a conceptual level, I should know what is the concept, different entity types, different attributes, the relationship, the type of the attributes, to understand more the map of my data modeling, how it will take. I believe that giving the type for each domain, it's more in the design level we can do this. Triggering operation, it is not part from the ER diagram, but it's part from the whole model, from your data model. Trigger, maybe the next lecture here, it can be better. Trigger, sometimes you will make a condition in your database, like by here, the entity integrity, it is a condition. It is a condition that should be always satisfied, which means that unique, null. Identifier cannot be null. Identifier cannot be duplicated. It should be unique. So it is a predefined condition that you have already defined, because when you said this is an entity integrity, sorry, this is identifier, which means that it should be null, and it should not be null, sorry, and it should be also unique. This is always satisfied. However, there are some conditions that you are going to consider this condition if this event will happen. I think from the word trigger, there something is triggering, which means that if I will be an instructor in a class, most of the students Well, after they are welcome to join the class. However, if one of them make a misbehavior after entering the class, he will be asked to leave the class. So leaving the class based on an event that happened plus a condition. The condition is he's a student in a class. The event happened, misbehave plus an event, a condition, sorry, is misbehave one. Event is entering the class. So after entering the class, misbehave, leave the class. So a trigger is related to event plus there is condition. If this condition doesn't happen, nothing happen. If it is happen, then an action should be done. Maybe later in implementation, we will talk more about triggers. Just here, we are going to define them. Example for this in the database and data modeling. I'll give you a real world example, but I can give you now also a data model example. Sometimes you create your data modeling and you create your ER diagram, and each ER diagram should have each entity type. And then you will go to the different entity types and you said that the attributes, sometimes a trigger can be related to a special entity type or can be affected by one entity or can be triggered by an entity type and affect another entity type. Suppose that the event will be, if we are talking about database, what will be the event? Either you insert a new data or you delete a new data, or you update a new data, or you select a data. This is the event will happen for a database model. So either you enter a data, or you retrieve a data, select, or you delete, or update. So the event will be one of this four in this case. The condition will be that if you enter a new data, which means that entering a new, suppose that you have an employee, you have, let's give you a table, let's say a trigger in a table employee. You are going to enter a data for an employee. And we should be aware that you are increasing a salary. You're entering a new salary. In many countries, I think Canada also like this. In many countries that you can increase the employee of a salary, but you can't, the salary for an employee, but you can't decrease it. It is working law. That labor law is most of the countries. And I think, I'm not sure about, but I think it is like this. That in some countries, the labor law said that you can decrease, you can make some different tickets, give him tickets, which means that whatever tickets, because he do something bad, you can give him penalty or ticket. However, as the salary itself, you can't decrease the salary, but you can increase. So in your employee table, you can't have a fixed condition for a salary. There is no. But however, when the salary will be updated, this is the event. When the salary should be updated, you can make a condition in the trigger that the new salary should be not less than the old salary. If it is less, the update should be declined. This is a trigger. Again, a trigger should be an event and a condition. It is not part from the ER diagram because it is not it doesn't talk about the entity types or the attribute or the relationship. And it doesn't talk about a predefined condition that we always have. Like, for example, the identifier should be always unique and also can be null. However, there is something that relates to event and condition. In our data model, the event will be either insert or select or update or delete. The example that I give is that about I can make a trigger for the table or the entity type employee. The trigger, I will give it a name. I said salary update. What will be? I will define the event is update salary. Condition, salary comparing new salary and old salary. New salary less than the old salary, update is declined. We have to define different triggers. We have it in this data model because later when we make the implementation, we are going to write a code for these triggers. There is, for example, SQL code for a trigger. To have the data always consistent based on the requirements that we have already gathered. Because we have already gathered the requirement for a firm or a company or that is work in a special country that it has a special law. We have to set of laws that we have to satisfy. Like the labor law. The labor law said the salary cannot be decreased. So me as a designer analyst should be consider this because you have to put all the restriction in order when you will have a data entry later. If you have a data entry later, you will not have inconsistent data is being entered. This is very important in the conceptual analysis and later in the design, logical design, to consider all this. And because later when the different users is going to use your system, you have to consider all restriction to have always a consistent data. Inconsistent data or that has a lot of bugs, it will make a very huge problem in the reporting system later. A lot of bugs, a lot of corruption, a lot of mistakes in the data, and then I will have a bad decision, or I don't have a data based on a report to take a good decision, maybe for development of the whole company. This was all what today we have already discussed. So we have discussed about conceptual data, entity relation diagram, entity types, attribute. We talk about more about different relationships, and we talk about supertypes and types, and we have already defined the 4 basic business rules that we have already discussed. So if you are interested, and I really recommend it, that we will have a group work exercise. I know that maybe you are tired that we have this group work exercise. You can practice. I can break you down to 2 groups and give you a question about how to write an ER diagram. You can practice this, and then I will discuss it with you. Who will finish it in a good manner, which means a good manner doesn't mean that he has to finish everything. Just because I don't expect you can finish everything now. You can get bonus for the assignment grade. Bonus can be for assignment 1 or assignment 2 based on your grade. Are you interested to have a group work? If you are interested, I want to have 3 thumbs up. Perfect. I will break you down into 2 groups, into two rooms. I will share you the lecture notes in each room because maybe you need it because we have already discussed this. And maybe I will share also the exercise. I will just give you an exercise in a very flexible way to do it like we have to do before. So see you now in each. I will now make the breakdown, and it will be not recorded one, so you can have your own private discussion. Each team has its own private discussion. See you as the rooms now. Let me break you down first. Yeah, so you will be, I open the first one. Now we will go to the room. I'll stop sharing. And also I will stop recording.